Hello everyone. Today I'm going to talk about nonlinear models. So most physical systems can be modeled with the help of a set of first order differential equations. So for example, x1 dot is equal to some function f1 of t, x1 to xn, un to up. Similarly, we can write x2 dot up to xn dot. Here x1 to xn represents state variables, un to up represents input variables. So state variable means it represents the memory of the system. Okay, and this x1 dot represents the derivative of xi with respect to t. It means that I can also write dx1 by dt. Similarly, dx2 by dt and dxn by dt. Okay, so any system I can represent with the help of these differential equations. Now I can represent this set of linear differential equations. I can write in terms of vector notation. So I am going to define x is equal to x1 x2 up to xn. U is defined as vector u1 u2 up to up, and f of txu, that is these functions I can put into a vector form, that is f1 f2 up to fn. Now I can write this as x dot is equal to f of txu, where x dot means this x1 dot x2 dot up to xn dot. Similarly, f is equal to this function. So I can represent this whole set of equations with the help of this equation x dot is equal to f of txu, where u is input, x is state. This equation we call state equation. X belongs to R n cross 1. It means that x is a vector with n rows and one column. Similarly, u is rp cross 1, that is p rows and one column, because number of inputs are p, u1 u2 up to up, so that's why p cross 1. We can have another equation that is called output equation, and this equation is given as u is equal to some function h of txu. So where u can be represented as, or the number of outputs are q cross 1. So y can be anything. Y can be the output of a system. Y can be the variable that is of our interest. Okay. So I will give you an example maybe in the next video where I will show you the model, uh, how to do that, all these things. And if you combine 1 and 2, so these two equations together we call state space equation or state space model. So now we know that this equation combined with this equation is called state space model. Now if I write this equation without the presence of u, then I call this equation as unforced state equation. Why are calling unforced? Because u is not present there. It doesn't mean that u is equal to 0. It only means that u is not explicitly present in the equation, because u can be the function of t, you can be the function of x, you can be the function of t or x both. So when you put this y is equal to some gamma function of x in the equation, the u will get removed. You cannot see u anymore. So ultimately you will get the final equation as x dot is equal to f of t x u. Now, a special case of this equation is called autonomous or time invariant. Why? If you remove t from here, x dot is equal to fx, this is called autonomous or time invariant system. Okay, so since t is not present in the equation, so the behavior is invariant, because if even if you put t to t plus tau, the system equation will not change. So we call it time invariant. And if the system is not autonomous, then we call non-autonomous or time varying system. So this was all about the basics, the nomenclature, the terminology that we use for the non-linear models. So please let me know if you don't understand any terms in this particular video. Thank you for watching the video.